Hi, welcome to the video solution for Edexcel Physics. This is Edexcel IAL Physics Unit 1, January 2017, and this is fourth video of the series. So let's start. Basically, what happened, there was a question that, due to editing or some mistake, it was not there. So let's first discuss this MCQs of that paper, MCQs number 3. So they are saying that when a force is applied across the end of a sample of a wire, the wire extends until it fractures. The force extension graph for the sample of wire is shown. So this is the force extension graph, and we have some points on the graph. A force F is applied to an identical sample of wire and then removed. If the sample of the wire is to return to its original length, what is the maximum force that can be applied? So basically there are two important points when we deal with force extension graph. One is called limit of proportionality, and the second one is elastic limit. So basically for this limit of proportionality, there are two things: that the material obeys Hooke's law and material remains elastic. But for elastic limit, material or the wire, whatever you say, does not obey Hooke's law, but still behaves elastically. And if you see the graph, generally the behavior of the graph is from O to Z. You see you have a straight line. So this straight line is showing that the material or the wire is obeying Hooke's law, and of course it is if you remove the force, it will return to the original shape. And after Z, there is a small interval, very small interval, in which you see you have a slight curve. This curve is showing that the material is not obeying Hooke's law because gradient is not constant. But in this small interval, material is still behaves elastically. So if you remove the force, even in this interval, it will return to the original shape. So the maximum force that can be applied is at Y, and after Y you have a very another small interval, and you have another point, and this point X is called yield point, after which you have a large extension. So the maximum force that can be applied and the material returns after removing that force is Y. So your option should be C. Question number 17 of the same series. A bicycle frame consists of hollow tube made from an aluminium alloy. This is a bicycle frame. To produce the tube, the aluminium alloy is pushed through a template as shown. So aluminium alloy is pushed, force is applied, and it is passing through from that template, and we have a hollow aluminium tube coming out. State and describe the property of aluminium alloy that allows it to undergo this process. Remember, this is a typical question, generally comes from material section. There are two types of forces that you need to understand. Number one is tensile force and compressive force. So if material is being changed due to tensile force, that means the material is going to undergo change in length. So due to tensile force, we have a change in length. So basically it's all about stretching. It's all about stretching. But if you are compressing something, that means it's all about uh, high pressure, something like that. And that means you can compress. So for due to tensile force, you can make a wire like things, wire or maybe tube. If you stretch, if you make tube due to stretching, so this is called tensile force. And then the behavior or the material is called ductile material, ductile. But if due to compression you have some changes in material, then this is called compressive force, and the material is called malleable. So in this case, in this diagram, aluminium force is applied to push the alloy. That means you are compressing aluminium alloy. So aluminium is behaving as malleable material. So that's how you can explain. I wrote AL just to save time, but you should write the whole the complete spelling, aluminium. A bicycle manufacturer gives the following data for the mechanical properties of an aluminium alloy used in their frame. So yield point is 276 megapascal or million pascal, tensile strength is 310 million pascal, strain on fracture is 0.12. So state what is meant by yield points and the tensile strength. So yield point is the position at or after which you have a large extension for a small amount of force. So if you recall the graph, you have a straight line and then slight curve here, and then you have another small interval and then large. So something like, so this is called limit of proportionality. Let's call it A, and the after that you have a elastic limit, and then this is called yield point C, after which you have a large extension for a small amount of force. So you can say that for a small amount of force like this, so you see you have a large extension. That's how you define yield point. And tensile strength is the maximum maximum force, maximum stress before breaking the material. And because we are using word tensile, so definitely you need to include the wire under tension or under tensile force. A tube made from this alloy has an original length of 80 centimeter. Calculate the length of the tube at fracture. So because we need to find the length at fracture, so if something we have original length like a rod or wire, whatever, its original length L0, and it is being stretched until it fracture. So before fracture it has some final length, let's call it L dash, and this is called extension before fracture. So clearly from the diagram, L dash, that's what we need to find. L dash should be equal to L naught plus delta L. We have L naught, this is L naught, but we don't have delta L. And for delta L, we need some other data so that we can figure out delta L. So now you can say that strain on fracture is 0.12. This is all about fracture, and as per definition, strain is change in length per unit original length, because I use L naught for the length, original length. So delta L is equal to epsilon into L naught. So epsilon is 0.12 times 80. Delta L would be equal to 89.2 centimeter. Finally, final length is equal to 80 plus 9.6. So final length is equal to 89.6 centimeter. This is the final length. Bicycle frames can also be made from an alloy of steel. The density of steel alloy is greater than the density of aluminium alloy. Explain why bicycle with aluminium alloy frame is better for racing. Indeed, if you compare steel and aluminium, steel in general we say steel is heavy and aluminium is light. And how can you compare? If you wish, you can compare their densities, because densities of steel is greater than density of aluminium, and we are using both of them for a same bicycle. So volume of aluminium and steel will be same. So volume used by for steel and aluminium will be same. So as per formula, density is equal to mass over volume. Definitely mass is equal to density into volume. So mass of the steel is greater than mass of the aluminium. So it will be heavy. So you can, if you wish, you can include all these information. Otherwise, you can just state the reason that steel is heavy, and of course you need more force if a frame is made from steel, or aluminium is lighter. So you need less amount of force to accelerate the bicycle. Question number 18. In an investigation of the jump of fleas, measurements were taken from a high-speed video. The body of a flea can provide maximum power of 600 watts per kilogram. 600 watt per kilogram. This is power. This is just not a power, remember. This is power per unit mass. So this is, it's not P alone, it is P upon M. Just keep this thing in your mind. A flea of mass 0.7 milligram takes 0.85 millisecond to take off from rest. Show that maximum velocity of flea is about 1 meter per second. So the idea is, I am going to use, because power is given in terms of rate of change of rate of mass, so power per unit mass. So I'm going to use energy formula. Time is also given, so E is equal to power into time, and of course this energy can be replaced, because we need to find the velocity. So this energy can be replaced by half mv squared is equal to P. Power is not 60, basically P upon M is equal to 60, not 60, 660 watt per kg. That's what you can replace P. So from here P is equal to 660 M. So power is replaced 660 M, 660 M into T, and time is 0.85 millisecond, 10 to the power minus 3. And clearly you can cancel mass, and now you can find velocity. So velocity V would be equal to twice of 660 into 0.85 into 10 to the power minus 3 of square over square root. And from here you can find velocity. So V is equal to 1.06 meter second inverse. That's the velocity of the flea. Calculate the average acceleration of the flea at takeoff. Indeed, this is the maximum velocity gaining, and it is starting from rest. and time is also given, so it's quite easy and straightforward question. Acceleration is v minus u upon t. So 1.06 minus 0 divided by 0.85 into 10 to the power minus 3. So acceleration would be equal to 1246.17. You can round it off and you can say acceleration is 1250 meter second minus 2. This is the acceleration of the flea. The measurements were repeated with many fleas. The average initial velocity of fleas at takeoff was 1.2 meter per second at 39-degree horizontal. So calculate average horizontal distance that a flea would travel. Basically, this is a typical question of a projectile, and you can imagine a flea takes off at the speed of 1.2 meter per second and making angle of 39-degree to the horizontal, and then this is 39-degree, and flea jumps and land here. So basically you need to find horizontal distance of that projectile. This is our prime target or prime requirement, S, let's call it S, and we are given only initial velocity and the angle. So there are at least 3 different methods to solve the problem, but I will give you just one, and the second one I will give you idea because we don't have much time to explain every method. So the first method you can use is just sweat equation, and what you are going, but see, let's make the idea. We need to find distance, and this is because this is projectile and we need to find horizontal distance. That means we will have to use S is equal to ut, and this u is just not 1.2. This u should be horizontal component of the velocity, horizontal component of velocity 1.2, meaning cos component. So you can say that S is equal to u is horizontal component, which is 1.2 cos of 39 into t. Problem is we don't have the total time of flight. This is the main thing that we need to figure out. And in order to find t, we should consider vertical motion of the flea or the projectile. That means we are going to use vertical motion to figure out time. That means you divide the whole motion into half, and you consider that flea after jump is going vertically upward and reaching at the topmost position. You know that at maximum height vertical velocity is 0, vertical velocity, and that's the advantage that we are going to take, and we are going to find time t1 for flea to take off and reach at the maximum height. And in order to do that, this is vertical motion, so we are going to use sweat equation, SUVAT, any one of the sweat equation. The best equation is V equal U plus AT. Now just how do you apply this equation? V is the final vertical velocity at maximum height, which is 0. And U, this U again is not 1.2. This U is initial vertical component of the velocity. So you are going to take 1.2 sine of 39 and plus A is acceleration due to gravity, which is minus 9.8. And why did I take minus? Because vertically flea is going upward and acceleration is downward, so minus 9.8 in opposite direction. So, and t is the time t1. So clearly t1 is 1.2 sine 39 divided by 9.81. You just rearrange for t1, and then t1 you will find as mm, 0.077 second. 0.077 second. This is the time for flea to reach at maximum height. And what about the total time? Total time is the double, so t is twice of the t1 from height to return to the ground for ideal condition. So that means total time is uh, 0.154 second, and this is the time that we need to find the distance. Then s is equal to 1.2 cos 39 into 0.154, and if you do that, your s would be equal to 0.144 meter. This is the horizontal distance. So this is the one method, first technique, and we use this technique frequently. Another technique is, because we are giving initial velocity, not the component, and we are given angle, so we can use direct formula for range, and direct formula for range formula, which is s is equal to, or range r equal to, whatever suits you, this is range, or s or r is equal to u square sine 2 theta divided by g. This is direct formula. You don't need to use time, you don't need to find time, you don't need to find components, sine and cos component. You just substitute value. So r is equal to u square. U is, you can put directly the velocity, because this is u square is not the component, this u is the velocity. So 1.2 square sine of 2 theta, twice of 39, divided by g. Once you solve that, you have the same answer. But I would not recommend, we can do that in this question, it should be acceptable, it is acceptable, but in some cases I have seen some marking scheme in previous years where examiner says that if a student is using that direct technique, so just give one less mark. So if 4 marks, so you might have only, you know, 3 marks in some cases, not always, but I guess in this question you will get 4 marks for all both of the technique. And there is another technique that I'm not explaining here, maybe in some other question you will see that. When a flea jumps, some of the energy comes from the leg muscles and some from compressible pads behind the back legs. The pads are made from a protein called resilin. Before jumping, the pads are compressed. On takeoff, the pads expand rapidly, transferring energy to the back legs of the flea. You can assume that each pad is a cube of size 60 micrometer, which fully compresses until the depth of the pad is negligible. So this is a model of a pad, a cube of 60 micrometer, and when it is compressed, so it is compressed from the top, so fully compressed, so only you have a flat surface. So for, it is just an assumption, for a particular jump, the total energy transfer from the pad and the leg muscles was 0.8 microjoule. Calculate percentage of energy for the jump that comes from the two pads. Young modulus of resilin is given and strain is given. So the idea is, we are going to find stored energy in the pads, because pads are compressed, so some material is compressed, so energy is stored. So energy stored is E is equal to half of F delta X. Delta X is the extension or compression. In this case, delta X is 60 micrometer. So delta X is we have, and we need to find energy from the pad, but we don't have force. And for force, we are given Young modulus. So since Young modulus, I generally use Y for Young modulus, is sigma stress upon strain. And strain is given as 1. This is epsilon. That means Y is equal to, so sigma upon epsilon. So Y is sm as, or sigma is sm as the value of Y, and stress is force per unit area. So Y is equal to F upon A as per definition of stress. And then you can rearrange for F. So F is equal to Y into A. You don't have to, show every step I am doing, so that you can understand. You can skip all the step that you understood or you already know. So F is equal to Y, and now this is the force that we are going to use, and we can find force because Young modulus is given and area we can find from these number. So energy stored is E is equal to half of F. F is Young modulus into area, this is F, into delta X. Now substitute the values. So half of Y is 1.8 into 10 to the power 6 into area. Area is 60 into 60 micro. Don't forget micros here. So 60 into 60, and delta X is also 60. So 60 into 60 and into micro. So micro cube, or 10 to the power minus 6, or minus 6 minus 6, 12 minus 18, so whole cube. You can do that, something, it's your choice. Now use your calculator and find the energy. If you find the energy is 0.1944 microjoule, and this is energy from one pad, because we considered only one pad. So this is from one pad. This is just for your information. And we need to find for two pad, percentage change for the two pads. So you can say energy from for two pads, so you can double the energy. So energy for two pads is twice of that. So energy for that, these are just symbol, you can use your own symbol. So energy, total energy for two pad is 0.3888 microjoule. Now you need to find percentage change, percentage of energy. So the total energy provided is 0.8 microjoule. So the percentage of energy is 0.3888 divided by 0.8. So this is 0.486, and that is 48.6 after multiplying by 100. So 48.6% of energy is provided by the pads. Suggest two properties of Resilient that make it suitable to assess with the jump. Clearly, Resilient is can be compressed easily. So it is, it can store a large amount of energy, and it has a high tensile strength, and these kinds of stuff you can just write. So it can absorb large amount of energy, high elastic limit indeed, and low stiffness. Thank you very much. I hope you understood whatever is explained, and thank you for support. Have a nice day.